Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to see about antenna arrays. So an array antenna is a system of similar antennas oriented to get greater directivity in a desired direction. So it is defined as the radiating system consisting of several spaced and properly phased radiators. So the total field produced by the antenna array system is the sum of the fields produced by individual antennas. So the antenna array is said to be linear if the individual antennas are equally spaced. So individual elements are termed as elements of the array antenna. So linear antenna array is a system of equally spaced elements. So there are various forms of antenna arrays. So first one, broadside array. It consists of an maximum direction of radiation perpendicular to the array axis. So antennas are arranged in equal spacing. And end fire array, where the direction of maximum radiation is along the array axis. So first one, broadside array. It is in which number of identical parallel elements are set up along the line drawn perpendicular to their respective axes. So the individual elements are equally spaced and they are fed with current of equal magnitude all in same phase. So it radiates in broadside directions, that is perpendicular to the line of array axis. So maximum radiation and relatively little radiation in other direction. So in this picture it is a radiation pattern of the broadside array which is bidirectional pattern. And end fire array, it is an array which individual elements are fed out of phase of 180 degree. So it is consisting of a number of identical elements fed with the current of equal magnitude, but their phases varies progressively along the line. So it may be defined as the arrangement in which principal direction of radiation coincides with the direction of an array. So in this diagram, the radiation pattern is shown where the array fed with equal current 180 degree out of phase. Next, collinear arrays. So here the antennas are arranged coaxially, that is end to end in a single line. So individual elements are fed with equal in-phase currents in the case of broadside array. So direction of maximum radiation on the perpendicular to the line of the antenna. So it also produces the bidirectional pattern. Okay, we shall see the two element array calculation. So it is used for getting the radiation pattern of the two element array. So consider array of 2 point sources with equal amplitude and phase. In this picture, two isotropic point sources are numbered as 1 and 2 along the x-axis, and the distance point is taken to calculate the radiation. So field pattern of two isotropic sources of equal amplitude and opposite phase is considered. So here the arrays of 2 point sources with unequal amplitude and any phase. So it also can be calculated. So first one, array of 2 point sources with equal amplitude and phase. Here we are going to calculate the fields at a great distance point P at distance R from the origin, and the origin is taken as the reference point for phase calculation. So the waves from source 1 reaches the point P at later time than the source 2. So there is a path difference. So we are taking the path difference as d cos theta meters using this calculation, and it is written as d by lambda cos theta in wavelength. So phase angle is 2 pi multiplied by path difference. So calculating the field pattern, sum of two fields E1 plus E2 involving the phase part. So E1 e power minus j psi by 2 is the field component due to source 1, and E2 e power minus j phi 2 is the field component due to source 2. So it is assumed that the amplitudes are same. So E1 and E2 are taken as E0. So the equation is modified and E0 is written. So from trigonometry calculation, we are using cos theta value. So modifying the E value is 2 E0 cos psi by 2, and substituting the phase angle value beta d cos theta divided by 2. So this is the field pattern, and in this picture the radiation pattern is shown where we are getting the bidirectional pattern along the perpendicular axis, and array of 2-point sources with equal amplitude and opposite phase. So when we are taking the equal amplitude of E naught and opposite phase is taken, so for this we are getting the end fire array pattern. So the radiation pattern is along the axis of the array. So assessment, first question is, for long distance communication, which of the property is mainly necessary for the antenna? So the options are high directivity, low directivity, low gain, broad beam width. So the answer is high directivity. Answer is option A. Second question, which of the following is false about the single antenna for long distance communication? So here the enlarging may create side lobes, no side lobes, high directivity is required and high gain is required. So the answer is no side lobes. Answer B. Thank you for listening.